three-dimensional structure of the solids and the packing efficiency of different types of unit cells. In this class, we will study about the imperfections in solids. See students, from the beginning of this chapter, we are studying that the solids will have a regular orderly three-dimensional arrangement, and they have both these crystalline structures. Crystalline solids have both short range order and long range order. But even though there will be some defects during that crystallization or during the formation of these crystalline solids, so these defects are called as imperfections in solids. So these imperfections are responsible for most of the properties of the crystalline solids, say for example electrical properties and the magnetic properties. So these electrical and magnetic properties are mainly due to the imperfections that are present in the crystalline solids. So these imperfections in the solids can be defined as the deviation from the orderly arrangement of the crystal lattice. So that is called as imperfections in solids. So these imperfections can be defined as the deviation from the regular three-dimensional orderly arrangement. So that is called as imperfections. So these imperfections can be broadly classified into two types. First one is these imperfections can be broadly classified into two types: point defect and line defect. See here, the point defect means these are the imperfections or the deviation from the regular three-dimensional arrangement at any one or more point or at one or more crystal lattices. So such a defect is called as point defect, whereas the line defect can be defined as the imperfections or the deviation from the regular arrangement in the entire row of crystal lattice. If the defect is at any one point or one crystal lattice, so such a defect is called as point defect. If the defect is in entire row of crystal lattice, so then such defects are called as line defects. So in this class, we will concentrate on the point defects, the different types of point defects, and how these point defects are induced or how these point defects will arise in the crystalline solids.